gone over them yet. We haven't Okay. All right. I want everybody to stop talking. Anne-Marie, turn around. Okay. I want you to check your work. You know when we do these, we never leave parentheses. We never leave these kind of weird looking fractions hanging around. If you got to this point, try to convert it into one. If not, that doesn't bother me as much as this bothers me. Don't leave it like that. I would try to resolve them into one, because generally that's what we usually, how we usually keep it. It doesn't bother me too much if you left it with the plus one. If you're getting the concept, convert one into the other, that's the most important part. Okay? Don't leave this. Don't leave me this. Finish that. Raise it to the fourth power and figure out what's going on here. Or multiply it by 4. Get rid of your fraction. Sorry.
Remember 9, why wouldn't you multiply it out?
No, that you can leave. That you can leave. If you wanted to multiply that out, you can. But since this will get you nothing else, you can leave it like that. Those you can leave. Those are factors. Multiple factors. Those you can. But these things with like the who's in them, radicals, don't leave me radicals.
Wait, for number 9, are we allowed to leave them in the square?
Yes. Oh. That you can, because that's your square thing. Yeah.
For 7, I got 4x equals c, but wouldn't it? Oh, I didn't square 4.
You didn't square the 4. You got to square the 4 and the x. Yeah, don't leave, in other words, don't leave this one where it's here. Bring it back down to this. Here. Kind of your call with the radical. If you left me the radical, you left me the fraction. You know how to take the radical out and make it a fraction, right? I'll take that one either way. If this is squared, that kind of looks a little weird, leaving a radical squared. So if you make it, pull this out, the one underneath the radical stays there, the one on top stays on top, pull it out as a fraction. If you left me with the radical, that would not bother me too much. These are more important coming down here.
Yeah, I didn't get 17. No, I didn't get 17.
Oh, okay, so treat a double angle as if it was an angle. It is a 2 theta, but just treat it as a regular angle. Because sine squared plus cosine squared of that, it is a particular angle. It just so happened we broke it down and then we multiplied it by 2. But just treat it as a regular angle. This should have a 2.
So you just... So we don't use the format?
You still use the format, just treat it as an angle. Treat it as one.
We don't divide by the 2?
No, never divide that by 2. The only time you can divide that by 2 is, you remember when we did the multiple angles and we found out that 2 theta was equal to 60 or 2 theta was equal to 90? Then we divided your angle by 2, but you can't take that 2 out of there. But just treat it as one angle. Just treat this as a theta. Just treat it as an angle. It's a double angle, but just when you do this, just treat it as an angle. And my fault, I should have mentioned that. It is a particular angle. So if theta was 30, this would be 60. It's still an angle. So if you plotted that, you should still get your ellipse. You'll still get an ellipse. And did anybody try to put it in your parametrics to see what it looked like? Did it look like this ellipse? Well, you should do. Well, this you really can't. But you should put this into your parametric and see that it looks like this ellipse. You'll see that it looks like this ellipse. You can't graph this ellipse as a function unless you separated this into y and took the square root of both sides. God bless you. So the concept is graph it in parametric mode. But then when you convert this, isn't this the same as what it looks like? Do you know what I'm saying? Like once you do this, both zeros. My 0, 0, it's going out 4, it's going up 2. I should be able to see that on my parametric one. This is the one I want you to graph in parametrics. Because you really can't graph this unless you really get y squared by itself and do the whole thing. But you should recognize your ellipse formula that it made that ellipse when you graphed it in parametrics. So the concept was graph it in parametrics to make sure it's the same thing. And just treat that as an angle. It is an angle. It just happens to be a double angle. But it still is an angle. If you want to keep this over 1, that's fine too. Usually I do put it over 1, just so that you see the denominator. So when you graph that in your parametric mode, you'll see this ellipse. When you get your ellipse formula, you'll say, oh, that matches up to my ellipse. You can kind of figure out where the center is and where the pieces are going. And if not, change your window a little on your parametrics. Don't make it go so wide. Spread it out a little bit so that maybe the scale only has to go to 5, or whatever it has to go to. You know, just figure it out and make it a little smaller. Or just start your window over here. So that make your scale bigger and you can count the spaces bigger. Play with this a little bit. Good?
They would give us one with like tangent.
You just might, but you know your formula. You can just convert that to a tangent one, right? So we divide everybody by cosine squared or divide everybody by sine squared, and you got your other two formulas. And then you plug them into that. The concept is that it converts to a rectangular one. So there's your tangent.
Oh, yeah, that's okay.
Means you didn't get that far.
I did, I just didn't know how to do it.
So you only have to know one. You have to know this guy. Remember I told you when we did this way back. This is the one you have to know. If you divide everybody by cosine squared, it gives you one of these. And then divide everybody, do it again, divide everybody by sine squared, it gives you the other one, the one with the cotangent. So this gives you the one with the tangent, 1 plus tangent equals secant squared. And then dividing everybody by sine gives you the cotangent one. So that's going to give you your hyperbola. When you get to this point over here, make sure you subtract this, get this to the other side. You want it set equal to 1. So make sure you subtract it, because that's your hyperbola. When you graph that, you should see your hyperbola graph. It graphs weird. Did anybody graph it? It graphs like this piece, that piece. It graphs weird. It doesn't just go like this. Try graphing that. Let's pull up your paths. These are good to graph. Oh, I'm in parametric mode. Perfect. All right.
So you just put like 1 over cosine.
1 over cosine. Don't forget. Oops.
That's
Yeah,
41.
41. Yeah. How'd I get a 1 there? Let's put this in parentheses. Don't forget, when you put this in, instead of the X, you're getting a T. So don't forget that. And this should graph. I don't know what my graph looks like. This should work. All right, why is mine not graphing? Did you guys get the graph?
Is it in degrees?
I'm in degrees. Yeah, I'm in degrees and I'm in parametrics and I'm, oh, this is why. Negative 360. I obviously didn't send it very far. There it goes. Did you see how it graphed? This one, this one, this one, this one. It graphed all weird for hyperbolas. But that should give you a hint of what your hyperbola looks like. Now, when you get this rectangular equation, Your X is first. My transversal is my X. My center is at my 0, 0. I can clearly count this to 4. I can't count the 3, but I can kind of approximate. There's my 3. I can kind of approximate it. So it totally looks like it's supposed to look. And last one is circle. I bet you okay with the circle? You can convert them or you can put them in first. This is really your format of a circle. This is like a special, this is an ellipse format, but it's still correct. It's still, because an ellipse, a circle is a special ellipse. But I would just keep it in your circle format. Your circle format looks like this. So whichever way you gave that to me, I'm fine with an ellipse format.
I thought we were chatting here. I was like, I don't want to be a part of this.
Okay, so let's read this together. An arrow is shot with an initial velocity of 205 feet per second at an angle of elevation of 48 degrees. Find where and when the angle will strike the ground. So when you shoot an arrow, here's your 48 degrees. Like, figure yourself to the ground here. Here's your 48 degrees angle of elevation. You shoot it. Where does it go? Up, straight up. Makes a curve, and then what happens? It comes down. There's your parabola. Now, in the past, you were only able to do this. So you're up here somewhere, wherever you're starting from. You come down, and then you hit the ground. Now, you were only able to either figure out time and a vertical distance, or a vertical distance and no time, but a horizontal distance. But now, with your parametrics, we can figure out both distances, and your time is going to travel like this. And we're going to see this on your parametrics. And we're going to be able to get really, really close to what we need. The bad part about this is we need 3 decimals. And you don't want to set your table or your time or your t-step too small, because this will absolutely take forever to ever hit the ground. So we're going to set it, and then we're just going to tweak it a little bit to find what we need to find when we get to that area. Now, you physics kids, this is your velocity. Here's my angle. This is the most important thing. See this T in here? This is my parametric. This is my time. One of the biggest mistakes is not putting that T in there. I've been doing this for years, so trust me. When I see kids, they'll say, I have nothing, it's not showing me what I need to see. I don't get a parameter. Where's my parameter? Where's my time? Because you forgot to put it in. So make sure you put it in. This T goes in here, this T goes in here. This measures my horizontal distance. This measures my vertical distance. This affects anything horizontally is in your X equals. Anything affected vertically is in your Y equals. So if I was laying on the ground, my intercept would be 0. I'd be fine. If I was 10 feet off the ground, I'd have to put that plus 10 into this guy, because this is going to affect my vertical. Wind speed affects your horizontal distance. It does have an effect on your vertical, but in all, it's going to affect your horizontal. It's going to stop it short or push it. The height of it is not the biggest concern as where it's going horizontally. So wind speed is going to have an effect in your horizontal. Notice the wind speed has a time, has a T also, because isn't speed like miles per hour? So you have a time factor in your speed. And wind speed, usually they'll give us like a feet per second, and we have to kind of convert things. Or they'll give us a mile per hour, and if we're in feet per second, we're going to have to convert your wind speed. But for now, we're just going to take a basic one. We're going to take this, we're going to shoot this arrow, and so he's going to start basically down here, and he's going to come up and end here somewhere. Okay, so now all we have to do is fill in your parts. He has no wind speed in this, so we don't need the wind speed part. He's not standing He's actually kind of laying on the ground doing this, but he's not standing on anything, and is not counting his arm. So just to give you a basic one, just convert these equations. So your x1 is going to be your velocity. Your velocity is going to be the same for both of these. This is how you're going to start. You're going to put your t. This guy is going to be a cosine. This guy is going to be a sine. Easiest way to start. Velocity, t, cosine, sine. My angle of elevation, excuse me, 48 degrees. Again, we're staying in degrees. I have no wind speed, so that's all I have for x. I have, I start here at the 0, so I'm okay there. This guy, I have to do this piece here. This is your gravitational pull. This is what pulls this arrow back down. You physics guys, it's probably like 32 feet per second divided by something else. Ours is negative 16. So that's what's going to pull this down. If you forget this piece here, which is another piece kids forget, then your arrow keeps on going and never comes back to hit the ground. So if you see a straight line going up, God bless you, look for that part. If you don't have a time, if something's weird, look that you forgot the T. Those are basically the only things that are going to happen. And it's really not that serious. You can find it. So I'm going to set the first one up with you. So we're going to come into your parametrics and we're going to put both of those in there. Put in your equation and then let's go to your window and talk about your window for a second. And don't forget your T. And any parentheses that you need to close, just be careful of your parentheses. It's nice because these keep the same angle, they keep the same time, they keep the same velocity. All of that is going to stay the same. So that's not too bad.
The two equations here, are we supposed to just have those, we're going to have those memorized?
Yeah, you probably, not even memorize, you'll get the feel of doing this because it's the same setup every time. By the time you do like 5, you see it. Velocity, t, angle, sine, that's what I say, start like basic. Put your velocity, your t, your cosine, your sine, and then you just have to think, what affects my vertical, what affects my horizontal, and then change that. But you'll do enough of these, you'll see it. You'll see it. It's nothing like that bad. Now, let's go to your table for a second. T-min, time. Where's my time going to start at? 0. What's my vertical going to start at? And my horizontal? My x-min, my y-min? 0. Could I have negative distance? Hopefully it's not going to go through the ground. It's just going to stop there. I only care where it stops. So all your beginning parts are 0. T-max, time. How long do you think it's going to take this arrow to hit the ground? In seconds. Like how many would you think? Okay, let's go with 10. If we don't see it hit the ground, we can always change it. So T-step, just start at 0.5. Now, this is where you don't have a clue because you don't know how far it's going to go vertically or horizontally. You have two choices. You can play with your window. I would pick a starting point and then just look at your table and fine-tune your window to that. Don't keep going crazy trying to fine-tune your window based on your graph. We'll go to your table. But for now, we got to put something in there, a little bit more than 10. So, give me a number. This is your horizontal distance. You're shooting at a velocity of 205 miles per hour. And this is, 205 feet per second. Sorry, feet per second. Feet per second. So I'm thinking how many feet am I going to go? Both ways, horizontal and vertical. So just give me a number. 2,000? Okay, 2,000. Okay, and now give me a number for your Y max. How high is this thing going to go?
1,000.
So you guys haven't shot arrows. Okay, pretty good. Pretty good. A little high on that one, but we can fine tune. Now, if you're going to fine tune, and we can absolutely work with that, you're going to go to your table. Here's your 0. Bring this up to the top. Okay, so what did we say to do? Go to your y equals. This is your mode first. Are you in 3? Oh, you are.
Oh, no.
You're not.
I thought I was.
Yeah, these calculators say, oh, reset. Like some of the algebra kids, instead of resetting their tables, they just reset the whole calculator. They do. It works for them. Okay, now, I want you to watch this for a second. Which one, X or Y, am I looking to get back to 0?
Wait. No, X.
I want you to think. Now, X is my horizontal distance.
Oh, no, Y.
Y is my vertical distance. Which one, X or Y, am I looking to come back to 0? Y. What's going to happen to my X? It's going to keep on increasing. This is a different concept for you guys. Remember, and your time, this is your time right here in seconds. See it? We're going to trace this in a second on your graph. But just so that you get a better feel for your table, watch this. Here's my Y. Did I turn yet? It started to increase. It started to increase right here. Did I start to decrease?
Yes.
Okay, so this is important to me. Somewhere halfway by 5. So 10 seconds is probably fairly good for me for the time, right? 10 seconds is probably good because I went up and now I'm coming back down. Now, here I am. I hit the ground somewhere between 9 and 10 seconds. Here's my horizontal distance. So if you have trouble with your window, you're going to look at your table. So you can fine-tune your window. Do we need to on this one? No, but we can fine-tune it. Say I did this and it didn't hit the ground. I look at my table, I say, oh, I had to increase my X. Rather than doubling it or doing it again, just go to your table. Especially with seconds, you're not that far. Sometimes it's a little annoying, but this isn't a bad one. So somewhere over here, after 9 seconds, I'm hitting the ground. Now, this is the bad part. We need 3 decimals, so we're going to have to get close. Everybody good with this so far? Okay. This is time. You've got 3 parameters. Time, horizontal distance, vertical distance. So my vertical distance, the highest it went is like 370, we'll estimate it. And your windows do not have to be exact. So if you wanted to fine-tune your window, and you wanted to go here, my X max, I could maybe fine-tune it a little bit, and you do not have to on this one. This one, what would we say? I'll make it 400, and I can see my graph a little bit bigger. It depends what you're looking at. As long as you can see a turn, and as long as you can do a trace, you're good. Okay, so now, you're going to trace this. We want to know when and where will the arrow strike the ground. So we know it's somewhere about 9 seconds. So when you hit your trace button, hit your trace. I want you to see what happens when you hit your trace. See your T0, your X, and your Y? All 3 of these are going to change. So watch your time. Hit arrow to the right. See your arrow going? See this? See your time changing, your X changing, your Y changing? Now, notice how it's changing. It's going by 0.5. Why do you think it's going by 0.5? That's what our T-step is. It's going by 0.5. Okay? Now I know somewhere over here, I want to look to see where my Y gets as close to 0 as possible. Okay, so here I am, right here, 9.5. See it? If I go one more, I'm well below the ground. So if I go up a little bit here, I'm going to be real close. Now, I can go to my table. Here's what I want you to do. I want you to say, table set. I'm going to start at 9.5. Okay, I'm going to just leave it at, let's say, 0.5 right now. Just go by halves right now. We're just going to play with this a little bit so that you get comfortable. The most awkward thing is when you're trying to look at your table saying, what do I look at? Where do I start? Start where you get the closest to what you're looking for. I'm very close right now to hitting the ground. If I look at my table, I can probably pinpoint it a little bit better. I'm still a little bit off, even though I did 0.5. Now, as close as you can go. So say I did this. Because I want 3 decimals, I want 0.001. But sometimes it's annoying to go through this. So watch. I want to get as close to this. This one's not so bad because we don't have far to go. We were at 3 point something. How far off were we from 0? Not bad. If you're too far off, advance your t a little bit more. Start your t a little bit later. Now, this is what I'm watching for. I'm watching for when this guy goes to 0. Or the closest as possible. See it? I still didn't hit the ground yet at that point. I got to go one more to hit the ground. So I'm going to hit the ground right here. So that's my time. When? Well, if I'm here at the positives, I didn't hit the ground yet, right? So I got to go slightly, unless it was exactly 0, and we probably could if we went 5 decimals, but we only need to go 3 decimals. So if you gave me 9.521, 9.522, I'm okay with that. But I need you not to give me 9.5. We have to go 3 decimals. So now, here I am at the ground. So my time, when is my time? Whoops. Oh, that's my, this is my time. My where is my x. Now, notice there's no decimals here. Scroll over it. You'll see the whole thing written out. That's how far away from you that arrow hit the ground. That's your horizontal distance. That's the where. I don't want to say 0. 0 means nothing. It means just that I came back and hit the ground. So my where will be 1306.150 feet. Okay, so I've got 9.522 seconds, and I am at 1306.150 feet. Make sense? Okay, a little different. You got 3 things going on at the same time. The trace is kind of cool. If we wanted to see how high it went, like what was the highest part before it turned, like what was your maximum height, we do the same thing. We trace. We come up here. We try to see where we're halfway. Somewhere over here, I'm halfway. Somewhere between 4.5 and 5. Yes? No, it won't work on this. If you try to do calc on this, watch. Second calc, try it, Bo. Second calc, you get these. You can do a value, but that's it. There's no max, there's no min, there's no zeros. You could put a value in here. Yes. The window? Yeah. Well, they're all going to change as you do these.
I know.
Yeah, they're going to slightly change. Now, let me show you something else. Bo had a good point. Oh, I won't change it for you. Sorry. Go to second calc, second trace. You can put a value in. So if you think you're pretty close to something, fine-tune it with your value. Look for, like if we're looking for this, go to 4.55, go to 4.56, see where we are. My advice is use your table when you get that close. Table set. I was at 4.5. I'm going to leave it 001. Do not change your t-step. If you change your t-step, this thing probably will never get done because your t-step, remember, is going to do this. It's never going to get there. So I'm at my table. I'm at my 4.5. Which one am I looking at, the X or the Y? If I want to know how high it is. The Y. So my Y, I'm looking for this to turn. Did it turn yet? It's getting real close. See, as they start to repeat, they're getting real close. So I'm 7, 1, 2, 3, 4, 5. Just keep watching this guy. If you find you're too far away, reset your table set. I could do this. I could say reset my table set. Let me start at 4.7. Let me go to 4.7 and start there. See what this is doing. I'm still increasing. Maybe I don't like that. I'm going to start a little bit higher. This should be getting soon before it turns. So I want you to play with these tonight. This is a very different concept. Maybe when you get here, sometimes you have to watch your decimals because it's these decimals that are changing. See them? They're so close. Okay, let me just have you try. One. Try number 3. Try number 3. Try number 2. 2 and 3. Try 2 and 3. Then we can play with that tomorrow.